In this video, I'm going to talk about how to find the maximum kinetic energy of the photoelectrons. The emission of electrons from a metallic surface when it is exposed to an electromagnetic radiation is called the photoelectric effect, right? So these photons are jumping out of the metal with some kinetic energy. We're going to learn an equation to find this kinetic energy. So this is the energy level diagram of an atom on the surface of a metal. Let's focus on a single electron on the surface of this metal. So these are the energy levels of the atom. Electron is in the ground state. So this is the ground state. Let's say the ground state energy level has an energy of 5 electron volt. This one 15 electron volt, 18 electron volt. These numbers are not accurate. In fact, these numbers should be negative because we are talking about electron, and to show that electron is bound to the nucleus, these numbers must be negative. But for easier understanding, I'm just using positive numbers. Anyways, the difference between the energy level matters more. This difference is 15 electron volt. That means an electron in the ground state, it has to spend at least 15 electron volt of energy to get out of this atom. We have learned a name for this, right? Minimum energy required for photoelectric emission to happen. That's the work function. So work function in the case of this metal is 15 electron volt. How do you write the equation for work function? So work function is equal to, we're talking about the minimum energy, right? The equation of energy is E equals HF. But we are talking about minimum energy. So H times minimum frequency, F0. What is minimum frequency? That's the threshold frequency, right? Minimum frequency above which photoelectric emission happens. W equals work function equals H times F0. So that's the equation for work function. And now let's say we have a source that emits a particular frequency of radiation. So this is my source, electromagnetic source. An electron can absorb or emit only one photon at a time. So let's focus on this single photon. Let's say the energy of this photon is 25 electron volt. How do you find the energy of this photon? We have an equation for that. Energy of photon is equal to HF. H is the Planck's constant, F is the frequency of the photon. Anyways, that number is 25 electron volt. So this photon, it interacts with this electron. Electron absorbed the energy from the photon. It cannot stay in the ground state anymore. Has to jump up, right? So the electron, it spent 15 electron volt of energy to reach the outermost energy level. Electron is here now. 15 electron volt of energy to reach the outermost level. That's the work function of the metal, right? Yeah. It's still got 10 electron volt of energy left. Using the 10 electron volt of energy, it will jump out of the metal. In other words, that's the kinetic energy of this electron. Okay, so what just happened? The photon has energy 25 electron volt. It transferred 25 electron volt of energy to the electron in the ground state. The electron spent 15 electron volt to reach the outermost level. The remaining 10 electron volt has been used to jump out of the metal. Or this is the energy of the photon. This is the work function of the metal. This is the kinetic energy, the maximum kinetic energy of the photoelectron. So that's the general equation. Energy of the photon equals work function plus the maximum kinetic energy. So no energy has been lost. The electron transferred 25 electron volt of energy to the electron. Electron used 15 electron volt to reach the outermost energy level. The remaining 10 electron volt has been converted to the kinetic energy of this electron. Okay, so let's say you're going to Global Village with 35 dirhams. Okay, the entrance fee is, let's say, 25 dirhams. So out of 35 dirhams, you are spending 25 dirhams at the entrance to get into the Global Village. The remaining 10 dirhams, you can spend it to buy some food, right? So 35 equals 25 plus 10. This is the money you have, energy of the photon. 25 dirhams is the work function of the metal, or this is what you have to spend at the entrance to get into the global village. So this is the work function. It's just the opposite. In case of an electron is trying to go out. In our example, we are trying to get into the global village, but kind of same thing, yeah. Okay, so energy of photon equals work function plus 10 dirhams. You can spend it to buy some food. So that's the kinetic energy. So energy of photon equals work function plus kinetic energy. I'll write that equation one more time. Energy of the photon is equal to work function plus maximum kinetic energy. Okay, now what's the equation for energy of a photon? HF, right? HF. What's the equation for work function? Work function is the minimum energy required for photoelectric effect to happen. So HF0, F0 is the threshold frequency plus the maximum kinetic energy. So how do you find the equation for the maximum kinetic energy? Take HF0 to the other side. It will be minus HF0. So HF minus HF0. So that's the equation for maximum kinetic energy. Now from this equation, how can we increase the maximum kinetic energy? So H is a constant, F0 is a constant for a particular metal, but you can change the frequency of the radiation, right? If you increase the frequency of the electromagnetic radiation, that will increase the kinetic energy of the emitted photoelectrons. Yeah.